Thank you to the Alliance Labs for helping me be here tonight, and thank you to all of you for coming out tonight on a weeknight. So, your job for the next period of time that we're here tonight, you have a few jobs. Number one, eat some food, drink some drinks so John doesn't have to carry it out of here. Number two, have fun. Your workday's over. Mine's just getting started here. So that's important. Have fun, ask questions, enjoy. My job is to keep you entertained and hopefully teach you a little something, maybe blow a few minds along the way. I'm going to try to expand your thinking on some concepts. How many people have ever worked in SEO here? Show of hands. Okay. How many people are just kind of trying to figure out what SEO is all about? Okay, good. How many people have heard of something called the semantic web? Hey, look at that, a few people. Good deal. Much of what I'm talking about tonight has underpinnings with that thing called the semantic web. And now that you know that, you can forget it, because you don't need to know that to be able to understand, have fun, and hopefully get something out of tonight. We're going to be talking about writing content for machines, making sure that the machines in our lives understand our content. So, feel free to start raising a hand, shout out. You don't even raise your hand, just shout out. What are we looking at here? A website, very good. Yes, give the man a cigar. All right, what is that website about? A book, a product, a company, a retailer? What's that? Services? Okay. Website services? All right. Anybody disagree with anything that's been said? Okay. So the point of me asking that is really just to encourage you to have faith in yourselves. When you look at this, it's no more, no less than what you see. It is a website. It's a website about services. The thing is that businesses, brands, product owners, retailers, e-commerce folks, anybody out there that has a website puts this kind of thing on the web all the time. And they figure when they put something like this up there, everybody's going to be able to just look at it and know immediately what it is. Here's the dirty secret, and this is why we're talking about what we're talking about tonight. When we see that, that's what machines see. Not nearly as interesting. Machines? What do I mean by that? Well, I mean a lot of things. I mean the phones and the laptops, the tablets, the watches, the TVs, the thermostats, the driverless cars, the Fitbits, all these things in our lives that have computers inside of them. Processors that are soaking up data and trying to interpret that data back to us as humans so that they can give us information. Information that humans put into that system to begin with. I also mean refrigerators and the computer systems that run all these things. That's an important key point. By machines, I also mean search engines and the bots that they use to crawl the web and get information from those websites that we put up. I mean social media networks. They also consume information as well as serve as a publishing platform. I mean companies like these that make systems and make devices that we use, make the software and the firmware, the machines in our lives that we're using. And all of this goes back. Everything that we have that we're going to be talking about tonight is based on a vague but exciting idea. I'm about to walk you through a little bit of history of the web. Bear with me a bit if this is not new to you. Just enjoy the ride. I promise you at the end we're going to tie it all together and it'll be fun along the way. Back in March of 1989, a lovely British gent by the name of Tim Berners-Lee was working at CERN in Switzerland. And he wrote a proposal. He submitted it to his manager, And the proposal was about information management. And it was this idea of taking documents and linking them together into a sort of a web, if you will. And this was the proposal that became the World Wide Web. And that proposal, if you can see up there at the top where that magnifying glass is, got the comment from his manager, vague but exciting, which I think is an adapt description of the web that we have today. Vague but exciting. So that vague but exciting idea became the web that we use today for so many things. The best thing that Tim did, though, was what he did with that idea. He could be a bazillionaire today, but he said, this idea is for everyone. I'm putting it out there for free. We're going to give this away, and everybody can use it to build their systems on it. It's a very cool thing that he did. I'm a big fan of this guy. So when he did that, people said, okay, well, I'm going to start putting stuff in that system. And if you think about it, it was a very exciting idea for businesses because suddenly they could put documents online and they could share them globally, cheaply, and in real time. That was a really powerful thing. So we started seeing HTML documents on this new web. Really lovely pieces of work. For any designers in the room, you're going to get a lot of ideas here, I think. Yeah, these were some early websites. Yeah, it was real pretty stuff. By the way, if any of you have not tried this yet, this service is phenomenal. This Amazon.com thing, they have books and all kinds of stuff. It's really neat. We put a lot of HTML documents on the web back in the 90s, not all of them useful. But we also put other kinds of documents. We put images up there, images of all kinds. That wasn't the only kind of document we put on the web either. We also put PDFs. We're still doing this. Videos. Anybody know what kind of file this might be? Audio files. Forms. Spreadsheets. Word documents. Text documents. By mid-94, there were 2,738 websites. That's websites. Now, within each one of those, there were obviously a lot of different documents. And all those documents were tied together through all these links. In order to navigate all those documents, we used a thing called Google. And there were other search engines in the early days too, but I just wanted you to know we used Google then too. But Google was a little bit different. It's a little blurry here, but over there on that side, there's a little drop-down where we could select the number of results we wanted Google to return for something. And we as users, as we started navigating this new thing called the web, we had to find tricks and things to get around it and get the results back that we wanted to see. We put in long lists of comma-separated keywords. We started using plus symbols to say, no, I want a result that has this and that. We put some stuff in quotes. All kinds of tricks to try to get the search engine to give us something back that was relevant and make that thing, that information, pop up near the top of the results. The search engines, meanwhile, what they were doing is they were looking at what we typed in and they were trying to match the strings of characters that we had typed into that search engine. Why? Because keywords, that's what they could do. They could look at those strings, they could try to find matches and give us results. A keyword-only approach doesn't always work, though. There are problems. And by the way, this is not a statement on this particular search engine. I was just trying to vary it up. They all had this challenge back in the day. So I would type in a word into the search engine, and I would get back some results. If I type in this word, M-O-L-E, I'm going to get back results about small furry animals and something on your skin. A Mexican spicy chocolate sauce, a river in the UK, spies, a company that makes lighting equipment for theater, a scientific measurement, a TV show that's a reality show from back in the day. Keyword search is problematic. How do you differentiate between what you're looking for and the things that they're giving back to you? This problem is still true today. I have a realtor friend in California whose name is Michael Selma. That was great for him until Michael Kors created a handbag called the Selma handbag. Now suddenly Michael Selma is finding his way down in search results when people look for him. Because keywords. Because keywords have problems. With this search, this was an old Google search result, I got 27 million results for MOLE. And I, as a user, have to call through that. It's a problem. Now, we have over 1 billion websites. That doesn't help the problem. This was just from a few days ago, so I expect that number has gone up. And again, those are just the domains. Those are the full websites. That's not the number of documents on the web. That's exponentially higher. Fortunately, the web and search have changed. So we're going to take a look at that. How we search has changed. We don't really put stuff in quotes with the wildcards and the pluses anymore. And the quote. We ask questions. Where can I rent this particular piece of equipment? And the search engines give us back pretty decent, relevant answers. There's Google on your left and Bing on your right. Same question. We ask literal questions. How many liters in a US gallon? How do I make French toast? And you'll see in this case, there's a nice answer to my question right here, but there's also another link down here that looks a lot different than that blue link that we had at the beginning of the search results. We've got a photo here, we've got a rating, there's some interesting stuff going on. Where we search has changed. We search in-page. This is the school district where my kids go to school. I was looking for information about their school specifically, so I typed in, Control F on my PC, and oh, there it is. It's on the page. We search in site, the search function on websites. We search in network, Facebook, Twitter. We search within search results now. Anybody seen a result like this before? So without even leaving the search engine results page, you can do an additional search. We ask questions verbally. We use devices like these to get answers. Hey Siri, okay Google, Cortana, Alexa, and we get really relevant answers back. We get good results. So search is getting better. But it's not perfect. This is a recent search for that MOLE character string. And the way that this has gotten better is Google has now provided me with some ways that I, as a human, can look at these results and make some decisions. So I'm going to zoom in on this a bit. This will work. Oh, by the way, this is more than three times as many results that we have to call through at this point. So it's still problematic. It's still not there. But they've given me some ideas here. This says mole animal, mole unit, mole sauce. So they're giving me some hooks into finding additional information. And over on the right, there's a panel about the skin moles and the furry animals and the sauce. So we're starting to get there. We're getting some additional help. But it's still true that when we as humans see this and understand it with our brilliant brains, machines still need help. They're still looking at this. And because of browser standards, they know how to take this information and display it so it looks good for us and our good brains. But it doesn't mean that the machines that are displaying it understand that information. We need to add something extra. We need to add some code. And the code is going to connect data, and it's going to make the information that we put into that page not only understandable to humans, but interpretable by machines. Let me pause for a second. So I'm throwing a lot at you. Questions at this point? You with me? Data? Good question. Data are information that is coded in a formal way so that machines can process it. That's how I'm using it for purposes of this. Does that work for you? Okay. All right. So what do I mean by machine interpretation when I say we're giving them information that they can interpret? I need to go back to Tim for a minute. The web does not have versions. You cannot go out to a software store and buy the latest version of the web off the shelf. You can't download a patch for the latest version of the web. The web does absolutely not have versions. So let's talk about Web 1.0. I'm doing this just for the purposes of this next section. And if you think about Web 1.0, think of it as a signpost along a timeline. So this is the early days of the web, all those documents that we were looking at a few minutes ago. Web 1.0 was all about linking documents. And then the search engines would go out and crawl through those documents to try to match those strings. So don't raise your hands, just shout it out. What is this document about? An awesome album of music. Okay, yes, everyone should get it. It is great. It is great. It's a collection of music. And we can look at that immediately and know that. This is a page that's pretty familiar to all of us, I would think. Pages like this. But the computer that's displaying it just sees these things: characters, formatting, and images. All of those documents are linked together by these things, URIs, those things that we type into address bars in browsers all the time. Web 2.0 was actually a thing for a while. Who remembers Web 2.0 and all the talk about it? Books were published, money was made by consultants, podcasts were recorded. Web 2.0 was a thing, and it was all about linking people. Some of these things about people. We started talking about all of these relationships between people. And those people were connected by links. My Facebook profile has a link. My LinkedIn profile has a link. Another really interesting aspect of this Web 2.0 world was now suddenly users who had no part in writing a web page like this initially were adding content to it. They were adding data to that system. They were adding reviews. Well, as a customer of this company, I didn't have any part in writing the page, but I can put content right in there. In fact, I can put content about the content, metadata about that data. I can say this review was helpful, and I can put another comment in there, another layer of data. So we threw more and more and more data into this system, which is exciting, except my computer is still stupid about all that data. It can't understand it. And this is why. We have the ability with our human brains to understand that context. When we look at that page about the album, that awesome album, we can understand what all those data points mean. The computer can't. It just knows, make that bold, make that blue, put that there, make that this size. It doesn't have the context it needs to be able to understand it. Which is where Web 3.0 comes in. Web 3.0 is all about linking data. Take a look at this page and imagine, what if we could tell the computer explicitly, hey, this JPEG isn't just a JPEG. It's a representation of a concept album cover. All right, we're getting somewhere. That's not just a string of characters, that's a band name. And that string is an album title. Media format. That number is a price in US dollars. And in fact, there is a comparable page at amazon.co.uk where a different number is represented in pounds sterling that's related to the same item. You can start tying things together across web properties. Now my computer's getting somewhere. We're starting to give that context to the computer. This is an important idea too. We're still using links to build these relationships. We're tying links to those pieces of data. We're saying that band name right there, we can identify that with one of these URLs. And that means we can reference it time and again. We can say that this album was by this band, that album was by this band, and they're referring to the same thing. Okay. For those of you designers in the room and people who are worried about load time, web speed, things like that, I want to show you a couple things here. First of all, for the designers in the room, this is how the code that we put into your website is going to affect the look of your pages. You need to be aware of this. So this is a web page that does not have any of that code in it. This is the same web page with the code in it. It doesn't do anything. It does not increment, it does not affect page load time. It's a tiny bit of, it's a tiny weight of code with very rich information under the hood. The important idea here is that there is formal code. There is a formal structure. And to your question about where does it find that information, well, I've defined here that this business is of the type general contractor. That's defined somewhere else in the web. I'm pointing to a URI that defines what the concept of general contractor is. Here I'm pointing to a postal address, and there's a definition somewhere of what a postal address is. So in the code, I'm pointing to those resources. And I didn't create those definitions, I didn't create those resources. We'll see in a minute where those are coming from specifically. But they're formalized and they're being used by many websites out there. This is not a new concept. Who has one of these in their pocket? If you do, you have something that is human readable and machine readable. When we travel with something that has human readable and machine readable content. What kind of data are we adding in the back end? Well, it's semantic data. And when I say semantic, for those of you who didn't raise your hands when I asked about semantic web, semantic means meaning. The same thing it means in linguistics or philosophy. What does stuff mean? And so this data carries meaning with it and communicates that meaning to the machines that are parsing that data. It's structured. There's a formal structure around it so that when those machines encounter these data sets, they know what to do with it. It's standards-based. The standards, by the way, are from the World Wide Web Consortium, the same good people that gave us HTML and CSS, XML. So it's stable. And you're not getting into vendor lock-in. The data is linked by those URIs so that it can be reused and so that, again, it fits into that formal structure. It's smart. It's just a really smart way to deal with the data that we're putting into the web. So who's using these? You know, is this stuff really real? Well, yeah, it is. It's being used by big pharma in the healthcare life sciences arena to enable drug discovery. It's being used in financial services. Big banks are looking into it to help prevent what happened to Countrywide Financial in 2008. If you remember 2008, Countrywide got into so much trouble because they didn't know the ownership trail of the mortgages that they held. And with this technology, they can track that internally. And they can track what their risk exposure is. So they're thrilled about it. Today, we're really focusing on the marketing, advertising, and SEO, SEM, but I wanted you to know that these technologies are being used across many vertical markets to great success. Here are some logos of companies that are using it. You may recognize one or two. Here's some more. I stopped there because it was getting silly. This company is using it. Back in April of 2010, something happened to the like button. Does anybody remember? Well, prior to that date, if you wanted to like a business or a product, you had to go into Facebook to their page that was about that business, about that product, and click a like button. On that date, Facebook broke the like button out of that ecosystem. It could now live anywhere on the web. That was a huge deal. It may have just seemed like a cute little marketing thing if you thought about what Facebook was, but it was a big technological deal because what they had to do was they had to use this technology. It's based on something called the Open Graph Protocol, which is not just used by Facebook, but they're by far the biggest user of it. The example that's given here in the introduction for those in the back says the Open Graph Protocol enables any web page to become a rich object in a social graph in a database. For instance, this is used on Facebook to allow any web page to have the same functionality as any other object on Facebook. That was huge. Suddenly, you could go to a page on a business site, click like, and you would like it in Facebook, and you wouldn't have to log into Facebook. They were just collecting the likes. But the other really interesting thing to note here is they were able to distinguish what it was you were liking. Were you liking the business that that page was about? Were you liking the product that that business was offering? Were you liking the second or third product in a page that had many products on it? They had to be able to tell the computer specifically what was being liked, and they were doing that using this smart data technique. So Open Graph Protocol describes these things. One of the reasons Facebook was able to do this and break it out of the ecosystem was they constrained it. And they said, okay, you will be able to describe these things and these things only. If you want to describe something outside of this, we're not interested. Good luck with that. This is what they wanted to be able to bring into Facebook from the wider web. These companies are using these structured data approaches. They saw what Facebook was doing, and they said, that's interesting. So they announced something called schema.org. Who here has heard of schema.org? A few people. Okay, good. Yandex, by the way, is the largest search engine in Russia. They came on board as a sponsor of schema.org after the first three that I mentioned started it. But they are an equal player at this point, and they're all sponsors of this project. In 2011, June, it was formally announced. It wasn't just announced on Google, it was announced by all the partners. And they said, schema.org is here. Great. What is schema.org? I'm going to let you digest this for a second, and then we're going to break this down into the two parts. So there are two parts to this. There's a publishing part. It's a collection of schemas, HTML tags, that webmasters can use to mark up their pages. Let's just focus on that part. So if you go to schema.org, you'll find lists of things like this. These are all things you can use to describe a product. A product has a description, an image, a name. It's the same as maybe some other resource on the web. It has a URL that you can associate with it. This is what it looks like. So here's a page. The background here is a web page describing a product. And on the back end, there's some data. This is a tool I use to parse and visualize semantic structured data on the back end. And here we have things where someone has used the data to tell the machine, there's an image, there's a photo of this product. This product has a rating value of 4.5. There are 266 reviews about it. It has a price of $14.99 in US dollars. It's in stock in new condition, et cetera, et cetera. A lot of really rich data that computers, machines can parse and deliver in different ways. So back in August of 2014, these were some statistics that Google reported on the adoption of schema.org at that point. So they scraped 12 billion web pages, and of those 12 billion, about 5 million, 6% of those domains had schema.org on it, which amounted to 2.5 billion pages, about 21% of that, 65 billion semantic statements. A semantic statement might be something like, this band has an album called this. 15 billion entities were picked up, those things that we're connecting. So that's pretty good adoption in just 3 years, August 2014. By December of 2015, there had been an increase, 31% of the pages that they crawled. So let's look at the second part of that. There's the publishing side, but then there's the consuming side, in ways recognized by major search providers. Now, Google, Yahoo, and Bing were and remain competitive with one another. So they've never been forthcoming about what exactly they would do with that data when they found it. They just said, we will recognize that effort, and we will do something with it. For those of us watching this space, though, we've seen evidence of what it is they're doing. In fact, sometimes they do tell us what they're doing. And it was about a year after schema.org was announced that Google told us, hey, we're introducing something called the knowledge graph. The knowledge graph is going to focus on things, not strings. And the knowledge graph is essentially going to be our database at Google. We're going to use it behind the scenes to deliver search results. Sounds interesting? I, for one, as a business owner, I want my company to be in the knowledge graph. I want my brand to be in the knowledge graph. I want my logo there. I want all the data about my organization in that knowledge graph. This is what it looks like. Suddenly, we started seeing the ads that used to be on the right side of Google go away, and we saw these panels showing up. All of this is based on rich, semantic, structured data that's been put into websites. We started seeing inline stuff like these ratings and the recipe image that I showed earlier. The results, the search results, just started looking prettier and more interesting than a plain blue link. You can use schema.org to mark up TV episodes. So here's a web page by the world's largest publisher. The BBC publishes 2,500 different things every day. Programs on BBC TV, radio, BBC America. 2,500, and they wanted a unique web page for each and everything they produced every day. The only way they could scale that was by putting semantic technology on the back end. And they scaled it by putting automatically some data in front of editors. They could say, yep, we want that, yep, we want that, in a very human-readable format. But they were using the power of the machines on the back end to cull through all of the data they were pouring into their system and display something where an editor could say, okay, these are the episodes that we want to add here. Or maybe there's some additional information at the bottom of this page about the characters that appear in this episode, or something like that. Maybe they know that there's an audio interview that was done with one of these actors last week on BBC Radio, and they pop that in here. So that's what the page looks like. But with that rich data, the search engines started doing things like this. This is a panel about a specific episode of that show. That's so cool. There's a panel about the show itself. Visually interesting, lots of images about it, a list of the episodes here where you could just jump to one of those episodes, and you get those cool inline things too with the ratings or additional media. That's all great. You have these big companies, B&H Photo, I don't know how much money they do in cameras every year, but it's a lot. They're a big internet player. The BBC is huge. What about small businesses? Why would they ever want to mess with this? Can they even afford to? Of course they can. This is a client, a Labrador breeder in Whitehall, Montana. Lives and breeds her dogs, and she doesn't make a whole lot of money, but boy, she's passionate about those dogs. So what was the benefit for her? Well, before we worked with her, this is what search results looked like for her. And this was after. She was in the knowledge graph with some really cool results, including the fact that she does a lot of her business through Facebook. And look what's there in the corner of that result. It's a pretty link to her Facebook profile, her business page. She started showing up in results like this, a map showing, hey, these are the Labrador breeders near you. Questions at this point before we keep going? All right. Premier Construction of Illinois had one problem here. That was competitive advantage. There are thousands of contractors in Chicago, absolutely thousands. And this is a small mom and pop operation. So if you were to go to search for something like Contractors Chicago 60634, this is what you get. Needle in a haystack if you're a brand trying to get noticed. After we had worked with them, they were number 3 on that list over to the left. I had to zoom in just to get to see them through that list of dots, but their information was right there. Again, tiny operation. They're not a big construction company. They're the company that you're going to call to renovate your bathroom, put new windows on your house. They do wonderful work. They do home remodels, but they don't build buildings like this. And in construction, in search, that's who they're competing against, the big guys. They wanted to specifically call out some of the cool projects that they had done as a contractor. So they built an accessible bathroom in Hoffman Estates. So we took that concept of accessible bathroom and that Hoffman Estates concept and tied them together. Because we knew Hoffman Estates isn't just a string of characters. It's a specific area, an area that has a map, an area that has latitude and longitude codes, an area that you can specifically point to with those URIs. And we can tell the search engines, hey, this project is about something that happened at this place. A remodel in Ravenswood, same thing. A rooftop deck in Logan Square, because we love our rooftop decks over around Lakeview. Okay. Another client. These folks are a publisher. They publish articles every day, they run conferences, they do webinars. They wanted to start competing better in a very competitive space. So we put structured data semantic markup behind the scenes, and now they're performing very well for pretty broad concepts, pretty professional, competitive concepts like business intelligence articles, data governance webinars, data management conferences. And by the way, for those in the back that can't tell, those areas, that's all paid search. Everything below that, down where the red is, that's organic. And that's what we're affecting here. We're not affecting paid search. Paid search, SEM, Google AdWords, that's still what it always has been. It's a useful tool, but we're affecting organic results here by giving the search engines exactly what they've been asking for since 2011. It's not perfect. Yes, John.
So those results, were they a result of adding content or simply marking on existing?
Good question. That is a company that, as I said, publishes maybe a dozen articles every day. So they're constantly adding new content. We set it up so that each article that would be published would be classified as an article and marked up accordingly with structured data markup. So content is added and structured data is added as they move along. The construction company, that one was a company that gave us their data, or their content. They said, this is what we want on our website. These are the stories we want to tell. And we just took it and we marked it up. No new content necessary. Now, this kind of exercise can inform changes to content. It can raise red flags for us and say, hey, you know, if you put this on there, we could talk about that. You know, on your page, you don't have bios of your C-suite folks. And they're really impressive people. You should get those people on your website so that we can tie your brand to those personalities, to their backgrounds, to where they went to school, to, I don't know, whatever you want to. The thing is that every company has great resources in the house. And all too often, they're not mentioning them on their websites, even in the human-readable content. So a lot of times, this exercise of putting in the machine-readable content calls our attention to possibilities for the human readable content. So it's a bit of a circular get back to it. Yeah.
There's also a bit of talk about sites affect the strategy.
Yeah, sure. Microsites really don't affect the strategy. As long as you can modify the code behind a microsite and publish it on the web, it can be treated the same way as another site. Good question. Okay. Let's talk about some of the problems with it. Schema.org, even though it was announced in 2011, is still growing. It's changing. It launched with 200-some classes of things that could be described, and that number has grown at least threefold by this point. It's a crowdsourced effort. It's an open community effort where people suggest changes, and then a core group evaluates those changes and says yay or nay. And then the stakeholders, those companies that are parsing schema.org on the back end, the Googles, the Bings, the Yahoos, but also many others. Apple parses schema.org in iOS. Microsoft parses it in Windows 10. Pinterest is looking for schema.org markup. So it's growing in adoption on both the publishing and the consuming end. But as it grows, to be honest, the tools to put it in place are still kind of immature. They're not great, kind of geeky and not pretty and not user-friendly. There's a big lack of understanding and misinformation out there in the world about what this stuff is, how it works, and how it doesn't work. So a lot of people and companies and brands get it wrong when they put the information out there. One of the reasons they get it wrong is meaning is difficult to automate. That semantic piece, it's really hard to mechanize. And people want those easy ways of processing these things, of setting them up. But as we all saw when we were looking at the web pages earlier, it's much easier for us as humans to understand the meaning of that kind of content than it is for machines to. So when you try to automate it, like say with a plugin, and there are plugins that will claim to put schema.org data into websites, and they do. And those websites will often pass the syntax tests, if you run it through a linter online. But there is no semantic test. All that means is that the syntax of the code is correct, but the meaning may be wildly off. Another problem is the vocabulary's changed. As I said, schema.org has changed. It has grown. But also in that time, there are some terms that have been deprecated. They started off in one direction. They said, this is a good way to describe something. And then they said, oh, maybe not. Maybe it wasn't broad enough. Maybe there's a conflicting term. And so they change it. And they try to be as least disruptive as possible. So how do those problems show up? They show up in this way. Global companies that may have a global presence and a global customer base are showing up in their websites as being local operations. Their headquarters is in Pittsburgh, so they start showing up as being a Pittsburgh-focused company, when their customer base may be worldwide. Maybe they're a travel agency. Old data conflicts. Company has an old logo and a new logo. The old logo keeps getting pulled up in search results because nobody has changed the markup on the back end that tells the machine, hey, this is our logo. Entities mismatched to concepts. Using plugins is a big offender toward this one. I've seen many websites that have a very common structure, and they'll say, hey, this is the section about our team. This is about the team members who work here. And you get down and you drill down and you say, oh, there's a really cool page about Carol. And you look at that page about Carol, and then you look at the data behind it, and it says, oh, this page is an article with a headline and a featured image and an article. Instead of, this is a page about a person with a name, a headshot, and a biography. And that person also has a contact phone number, a contact email, social media accounts. There's a lot of things you can describe about a person. That person used to work at company X, they went to such and such college. There's so much that you can describe, but if you're telling the search engines that that's an article, they're going to treat it like, oh, it's news. Okay. So it's just another blog post, just another news item. It's not about something concrete. So that's another pitfall of working with plugins. And in those cases, those incorrect signals are being sent to the search engines. So it's almost worse than not doing it at all. Another thing to let you know about, schema.org is really exciting, and it gained a lot of attention at these technologies and these practices, but it's not the only game in town. Back in May of 2007, there was a project that was sponsored by the World Wide Web Consortium, the W3C, to put some key data sets online. And so they did. They got the CIA World Factbook online and US Census data, Project Gutenberg, all about books. They also got these three. So I'm going to talk about these three just to give you a quick example. Music Brains is all the information that when you put a CD into a computer, all that stuff that pops up about the CD. Track names, length of track, band, maybe even band members. It depends on how much data has been put into the CD. FOAF, F-O-A-F, is friend of a friend. And that's an interesting data set because it doesn't reside in any one place. It's friend of a friend describes people and our relationships, our likes, our dislikes, that kind of stuff. I have a FOAF profile on my website. Other colleagues of mine have them on theirs. So that data set exists all over the world, multiple places, but they're tied together because of those URIs. DBpedia is the information that's in the info boxes in Wikipedia. If you as a human are looking at a Wikipedia page, it's the stuff that you see off to the right, the facts about the thing that you're looking at. That's the information that's in DBpedia. By July of 2009, that dozen sites had grown to this. By September of 2011, it was this. By August of 2014, it was just downright silly. We can't even fit it on a slide anymore. And they color-coded it at this point so that you could see that a bunch of these data sets over here were about the life sciences medical space, and a bunch over here were about publishing stuff, and over here you saw stuff about geography and music, and they had to start dividing it up in that way, color-coding it. Huge effort, but a lot of really exciting data sets out there that are available to use. This is a fairly recent one. The good folks at Wikipedia, the Wikimedia Foundation, saw what DBpedia was doing with those info boxes and those facts, and they said, that's fantastic, but it's done by a third party, and there are some downfalls there. It means that third party, the folks at DBpedia, download the content from the Wikipedia info boxes, put it through a semantic parser, mark it up, and put that data online as a semantic data set. So it's not real-time data, and it only gets refreshed quarterly. So it's problematic. Things change. So Wikidata came around, and they expanded it. And they said, well, we own that data, so we can make it much more real-time, and we can affect more than just the info boxes. So Wikidata is a way of identifying all those things you see in Wikipedia in a semantic way that can be used for SEO purposes, for marketing purposes, or for whatever other purposes you may have as a developer. The data from those data sets is machine interpretable by its very nature. Okay. I want to talk about another big business benefit here, and that's future-proofing. This is something that you get from this approach to SEO that you don't get from other approaches to SEO. The search engines are constantly changing their algorithms to look at different aspects of web pages, to determine what's relevant and what's not. So back in 2009, 2 years before schema.org was even announced, 3 years before the knowledge graph, My wife had a little business in West Hollywood. It was a nail and waxing salon that catered to mothers of young children, pregnant women, and really anybody that didn't want to walk into a toxic nail salon with all those fumes and chemicals and everything else. So they used low-fume, non-toxic stuff. They had a children's play area. It was a very targeted market thing. And at the time, the big news in my technology world was that Best Buy was using this semantic technology stuff to mark up their products and their stores and draw attention on an SEO basis to their properties. Again, 2 years before schema.org, Best Buy was doing this. It was very exciting. Best Buy was on board. And I was evangelizing about these technologies. I was going around teaching about them, and I would get the same two reactions from every audience I spoke to. They would say, "That's great. It's Best Buy. That means it's real. This is legitimate. It's being used by a commercial entity that found value in it and said, yes, we're going to do that." And at the same time, the audiences were saying, "That's great, but it's Best Buy. Best Buy has deep pockets. Best Buy has a deep technical bench. I'm not Best Buy. My clients aren't Best Buy. You're telling me this stuff is easy. Where's the value for the little guy?" Well, I said, you know what? You're absolutely right. I have a business in the family, so I'm going to put my money where my mouth is. And I spent an afternoon putting structured data into my wife's website. You know, it's a business, so it's got information like a contact phone number and a physical address. It's got services that they offer and prices for those services. It's got a lot that I can describe and tell the machines about this business. Within 1 hour of my finishing that work and announcing on Twitter to my geeky community, "Hey, guess what I did? I got this in an email." So let me tell you what this is. Within an hour, I got back a satellite view of the shopping center where my wife's shop is with some data in it that says, hey, this is a business entity with a URL. And it has a longitude code and a latitude code. Here are some other references about that business. It has a point of sale. It has a physical address. It has offers, things that it sells. Within an hour, somebody was picking up, parsing that data, and doing something really cool with it. It ain't pretty. It needs graphic design help. It needs user help, user interface help. But I don't care, because within 1 hour, that meant that I, as a business owner, had put data into my website that somebody was picking up and was in the process of developing an app around. So that maybe 3 months from now, after they put all those other pieces of work into it, the design and the user interface and everything else, a busy mom walking in the neighborhood who was pushing a stroller and found, he's asleep, I can get a mani-pedi. She'd be able to pull up her phone and say, where can I go to get that done? Guess where she can go. And I've already done the work. I don't have to do anything else. I don't have to contact the app developer. I don't have to write anything. The code is there to be picked up. 3 years later, when Google came out with the knowledge panels and the knowledge graph, our data was already there. So we showed up in the knowledge panel. Boom. Didn't have to do a thing. It was just there. Why did this work? Because it's just data. We're encoding data that machines can understand. So if an app developer is smart enough, savvy enough to say, yeah, I'm going to be consuming data. I'm going to look for data. We're going to find it. We're going to find that business. I want to bring back that refrigerator. Because I initially threw it up there kind of as a joke. I mean, yeah, we can write content for refrigerators. Why would anybody want to do that? Well, what if you have a recipe site? The screen on that refrigerator. In fact, what if someone wants to read the morning news at the refrigerator? Or watch a show while they're cooking. Maybe a cooking show. That would have been a better choice for that. Listen to the radio. Pull up information about what's going on at their kids' school today. What if the refrigerator breaks? Call the repair service. I think there's a lot of possibility here. And the limits are really those of being creative with our brands, with our products and services, with how we're putting them into the web so that they can be discovered and found and reused by all the various places that our customers are looking. Siri looks out for this stuff. Cortana does. Windows phones certainly do. So it's going to continue. And I encourage you to seriously consider this kind of an approach if you're putting content into the web. Make sure that not only it looks good for the humans that you're trying to reach, but that the machines along the way that are helping your users find your content are able to parse it too. Okay, thank you.